Okay, today we're going to learn about absolute and relative growth rates. And really, we're going to spend the entire day on the special situation where the relative growth rate is a constant. And so it's going to seem like the same old to you guys, because essentially it's exponential growth and exponential decay. But it's just, so we're going to be dealing with exponential growth and exponential decay, but in a kind of a new way. But it's going to be the same old, so don't be afraid. You know, tonight's homework is going to be pretty easy. But then tomorrow, we're going to learn about a special situation where your relative growth rate is actually proportional to not a constant, but proportional to something else. And that's going to give us logistic growth. And I'll talk about that tomorrow. But for now, just exponential growth today. So let's define absolute and relative growth rates and then talk about the simplest model. Here, let me get my notes. Okay. And let me remind myself what I do. All right. Okay. Okay. Here, absolute growth rate, relative growth rate. So imagine I play poker, and I play a bunch of poker. I go to Vegas, and by me playing poker, Mr. Shana playing poker, I take my $1,000 and turn it into $5,000. I had an incredibly successful weekend of poker. Meanwhile, Bill Gates, he takes his $100 billion and does some normal investments with it. And now he's got $101 billion. Tell me, who did better?
You did.
How many people think I did better? How many people think Bill Gates did better? Sure. And you know what? It depends what you're looking at, correct? It depends what you're looking at. Like absolute growth rate, okay? We call this mathematically just dp/dt, okay? The rate of change of some quantity with respect to time. Absolute growth rate. So the units of absolute growth rate are going to be things like people per year, if you're looking at like population growth, or maybe money per year, or if you're looking at bacteria growth, maybe it's the number of bacteria per minute. You know, I don't know, but it's going to be an absolute growth rate. So judging by absolute growth rate, who did better, me or Bill Gates?
Bill Gates.
Sure, what was Bill Gates' absolute growth rate here? $1 billion per year, right? Bill Gates, his absolute growth rate, if my P is going to be money, his absolute growth rate was $1 billion a year, right? Whereas Mr. Shana's absolute growth rate was what? Yeah, $4,000. But I guess it'd be $4,000 per weekend. So maybe if I did a lot of weekends, I could maybe, well, I wouldn't get up to $1 billion, you know, in a year. But we all understand that Bill Gates had the better absolute growth rate. But relative growth rate is something different, and I think when people were voting for me, they were actually thinking about relative growth rate, correct? Because relative growth rate is this. It's the rate of change, the absolute growth rate, divided by how much you started with. dp/dt over p. That's your relative growth rate. So now, let's look at Bill Gates for his relative growth rate. He earned $1 billion in a year. $1 billion per year. but he started with $100 billion, right? So what are the units of his relative growth rate? Well, I hope you see that the dollars cancel, the billions cancel, and all you get is year. And in fact, in this case, it'd just be 0.01, 1 over years. But we usually don't express relative growth rate as just the decimal 0.01. How do you suppose we express that? If we want to talk to someone and have it make sense, someone asks me, hey, what was his relative growth rate? I wouldn't say 0.01 per year. What would I say? 1%. Yeah, 1%. Good for you guys. So you guys are good at that. You've experienced that enough that you call it 1% per year. And so that was Bill Gates' relative growth rate, 1% per year. You know, which for someone of his money, that's probably not good. Someone would probably look at his financial planner or financial advisor and fire him. Because someone who has $100 billion should not only be making 1% a year, you know. I mean, they can get that just by lobbying Congress and having them pass a law to reduce their taxes, you know, which is what's happening now. Okay. And then you got Mr. Shana, dp dt b over p, and you tell me, what's my relative growth rate? How many percent is my relative growth rate? Well, you think 500, but actually the change of my money, where is that? Oh, here it is.
Oh.
Yeah, the change of my money was 4,000. I gained 4,000. So it'd be $4,000 per weekend, okay, over my original amount, which was $1,000. So that ends up being 400% per weekend. Okay, so in that respect, yeah, I did a lot better than Bill Gates. I kicked his butt, you know, and that's what's so attractive about gambling. You know, gambling, you can always have much higher relative growth rates than even wealthy people. So that's why I would totally recommend, you know, if you want a high relative growth rate, you need to go out there and gamble. Just gamble as much as you can, you know. Great. All righty, and so the units, remember here when I talked about the units being people per year, money per year, bacteria per year, here the units end up being just percent per year, or percent per minute, or percent per whatever time, you know, month, percent per whatever time, you know, you have. But the units are always just percent, and so now it doesn't matter what it is. Okay. Well, hey, that's absolute and relative growth rate. So I'm embarrassed to be doing this. And just 1 second. Okay, great. The simplest model. The simplest model of relative growth rate is to just have dp dt over p equal a constant. That's our simplest model. That would be like saying, hey, you know, Mr. Shana has a relative growth rate of 400% per weekend. We can assume that every weekend he's going to go out there and make 400%, which obviously isn't true. You know, in fact, I lose, you know, when I play poker, I lose maybe 38% of the time. I win 62% of the time, lose 38% of the time. That's when I keep track. I've kept track, and so I know that to be true. So, you know, you can't count on me having that sort of absolute, rather relative growth rate. But let me see here. K is a constant. Alrighty, and so, of course, this becomes dp dt equals kp, and then we learned previously that when I solve this differential equation, we end up with p equaling p naught e to the kt. And so this is something that we've already dealt with. So let me just give you a couple of examples. Have you guys do a couple of quick examples, and then I'll move on. Okay, here comes the example. Suppose K is equal to 0.08. So my relative growth rate is a constant 8%. And P naught equals, let's say, $1,000. You want it to be $1,000? Oh, let's make it 1,000 people. 1,000 people. Alrighty. So I'm starting off with 1,000 people. Let T be in years. Alrighty. Well, I'm going to ask you to do something just really simple. Get me the differential equation. And the solution. And this isn't requiring any thought. I'm just asking you to mindlessly plug those initial values into those, just so you just get used to that. Get used to the fact that one is the same as the other. Alrighty. So by now, let's see, where's my blue pen? Did I run out of time? Okay. Then hopefully you guys got dP dt equals 0.08p, and hopefully you got that p equals 1,000 times e to the 0.08t. Did you guys get those two equations? Okay, great. Hey, it's that simple. So let me give you another one. Here. B. Suppose I told you that, whoops. Yeah. Oh, shoot. I don't know why I even did these problems like this. Let's say I have that differential equation. Wait, no. Oh, I'm so sorry. I'm fiddling around. I'm embarrassed to have this videotape now. Differential equation. Find the relative growth rate. And suppose P is number of bacteria and T is in minutes. Okay. What would the relative growth rate be? Hey, I hope you're getting that your relative growth rate on an equation like this, your relative growth rate is a constant, and it's just that guy right there. You know, your relative growth rate is going to be 15%, and since I told you time is in minutes, it'll be 15% per minute. Is that okay with you guys? Okay, so that's all I got there. Now, here's the thing. This relative growth rate, this K, is called the continuous relative growth rate. And I really have to make a distinction between it and your annual growth rate, or what we in America by law call annual percentage rate. So I just want to make this really clear. K is continuous relative growth rate. Alrighty. Let me give you an example of the difference between a relative growth rate and an annual growth rate or annual percentage rate. Okay. Here comes an example. Okay, I put $100 in an account that compounds continuously. That is, it doesn't compound every month or compound every day, it compounds every moment. And after 1 year, I have $107. I think everybody in here can tell me, what's the relative growth rate? What percent did I gain? 7%, right? But that's not my continuous relative growth rate. That is the percentage of interest that I'm getting compounded continuously isn't 7%. Because if I had an interest rate of 7% that compounded continuously, I would make more than $7. Okay, so my relative growth rate, in this case, we in America, we call it the annual percentage rate, which we abbreviate APR. And if you look in the papers, I should have brought one, usually I have it, but in the paper, whenever you look at either banks that are loaning money or companies that are asking you to buy a car and to pay for the car on time, they'll always quote the APR, meaning the annual percentage rate. And that's what I found here. This annual growth rate is 7%, 7% per year, but it's not what K is. The continuous growth rate, K, has to be found as follows. I have to go, hey, P equals, I've got my P equaling 1.07 times P naught, okay? And that's gonna equal P naught e to the KT. What I've got is my final amount of money is 1.07 times my initial amount of money, and that 1.07 times my initial amount of money is going to happen after 1 year. So maybe I should put when t equals 1, p equals 1.07 times p naught, So now I'm going to solve for k. The p naughts cancel, and I get 1.07 equals e to the k, or I get log natural of 1.07 equals k, and so I end up with 0.0677 equaling k. And so that's my continuous relative growth rate. Yeah, the fact that no matter how much money I put in the bank account, after 1 year I'm going to have 7% more. So that's where this is coming from. This is just saying, I could have done this. I could have just, instead of doing that, I could have said 107 equals 100 e to the KT. Maybe I should have just done that. Yeah, I don't know why I did that. I was just trying to generalize, but really all I had to do was this. And say that, hey, after 1 year, if I start with $100, I end up with 107. That would have been just fine. I don't know why I did it that other way. I don't know why I did it in my notes. I must have thought that there was some reason. But right now, that reason escapes me. So what happens is if you had an ad in the newspaper for this bank account, the bank account would advertise, we have a 6.77% percentage rate, or 6.77% interest rate, but then in parentheses they'd have to say APR is 7%. Your annual percentage rate, what you'll actually earn on your money at the end of a year, is 7%, because our interest rate is 6.77%. So that's why I'm trying to really make a distinction so that when you go out into the real world, like, you know, I recently had to refinance a house, actually it was my brother's house. And I was going online and I was seeing all these different quotes, and they'd quote you, you know, 3.5 percentage rate, and they always had to quote you the APR as well, you know, because the 3.5 percentage rate isn't what you're actually paying. What you're actually paying is coming as a result of that. And then they add different fees onto it, and that raises the APR as well. But hey, let me give you a problem you can do. I'm hoping that this makes sense to you guys, okay? Here, try this. A country's population rises from 1 million to 1.2 million in 1 year. Find the relative growth rate which, like I always say, in America, because this is by law, we actually passed a law that says people have to tell you what the APR is. So find the relative growth rate, the annual percentage rate growth rate, but then find K, the continuous growth rate. And to find K, you'll do it the same way I did it here. Do it that way. Forget this. That's kind of dumb. Then we're going to deal with the United States population, and it will be good. By now, everyone should have gotten Part A is 20%. But hopefully the relative growth rate, now you're looking at P equals P naught e to the KT, so your final amount is 1.2 million. Your initial amount is 1 million times e to the k times you did it in 1 year, and so you end up with 0.2 equals e to the k, or the log natural of 0.2 equals k, which ends up equaling 0.182, or 18.2%. Okay. How many people got 18.2%?
Wait,
go ahead.
Why'd you subtract 1 from 1.2? You need to divide by 1 is just 1.2.
Oh, whoops. Boop, boop. Thank you. I wasn't thinking. It's just, you know, holiday, 9 days off. I just taught my daughter how to play Clue, so I'm like still dealing with that sort of way of thinking. Okay, which she didn't enjoy the game Clue, which surprised me, but maybe if I try it again, she'll like it better. I don't know.
She didn't?
No, I think, I don't know. I don't know what it was. She doesn't like deductive reasoning or something? I don't know. I don't know. How many people liked playing Clue when you were younger? Oh, well, not a lot of you. Okay, like 6 of you. Okay, great. So there we go. It is now time for us to apply this knowledge to the population of the United States of America. The U.S. of A. Population of the United States of America. Here comes the year. Here comes the population in millions. The absolute growth rate. And then the relative growth rate. Okay. Here come the years. Here come the populations, 3.9, 5.3, etc. Okay, so here's the first thing I want to ask you. Why is it that why do we know what the populations are every 10 years? Why would we even go to the trouble of doing that?
Census.
Yeah, the census. Tell me, what famous document tells us that we must take a census every 10 years? The United States. Thank you, brother. The United States Constitution. Absolutely. So yeah, so we got to take a census every 10 years, and that's what we do. In fact, we got a census coming up in 2020. And why do we have to take a census?
To monitor growth.
What's that?
To monitor growth.
Nah, we don't care about growth. Why do we have to take a census?
Tax
The
and
economy.
No, not taxes. What?
The economy.
No, not the economy. Oh my God, you kids. Thank you very much. Look at Axel. Axel's not even American, and he knows this. No, it's just kidding. That's on video now. No, but yeah, to determine how we apportion our representatives, right? That's why California gets more United States representatives than anyone else, because we got more population. Thank you, Axel. I was kidding, of course. I know. I'm just trying to be really funny, but I'm not sometimes. Okay, great. So for each decade, we're going to calculate absolute growth rate and relative growth rate. Here we go. Absolute growth rate, 1.4 million, right? And do you mind if I do absolute growth rate? If I tell the world that my absolute growth rate is in millions? Absolute growth rate. And that's going to be in millions, so I don't have to keep writing the word millions after every number. 1.4 million. Okay, so please fill out the rest of the absolute growth rates, and I will do the same. Make sure I don't make any mistakes. Is that right? 1.4, 1.9, 2.4, 3.3. Okay, after you've got these absolute growth rates, I'm now going to calculate the relative growth rate percent per decade. And that's going to be absolute growth divided by the population you started with. So you started with 3.9, you grew 1.4, and now you've got this growth rate here of 0.36, which is 36%. Okay? So please do the same for each one of these guys, and so will I. Are you guys getting those percentages, 36, 36, 33, 34, 33%? What do you notice about those relative growth rates?
It's decreasing.
Say again? Was it,
They're declining.
who's talking?
Yeah.
Lauren, tell me, Lauren.
They're declining.
Okay, they're declining, but really declining? That one didn't decline. Yeah, I would say staying the same. I mean, I think it's pretty amazing that for the first 50 years of our nation's history, our relative growth rate was virtually constant. We had this situation for literally the first 50 years of our nation's history, where the relative growth rate was pretty much constant. Okay? In fact, if we were to take the average of those 5 relative growth rates, here I'm going to do that right now, 36 plus 36 plus 33 plus 34 plus 33 divided by, what, 5? I get an average of 34.4%, okay? So that's my percent growth rate per decade, alrighty? Now, this is my relative growth rate per decade, but what if I want my continuous relative growth rate? Okay, I want K. Well, K isn't going to be 0.344. That's just telling me how much I get per decade. I want K, if I want K to be my continuous growth rate per year, let's say, I want K to be equal to the continuous relative growth rate per year, not per decade, but per year. Then I'm going to have to do this sort of thing. I'm going to have to say, hey, P equals P naught e to the kt. I get to use that because it looks like it's a constant relative growth rate. Whatever my P naught is, after 1 decade, after 10 years, my P appears to be 1.344 times P naught. And that's why I was doing it that kind of dumb way before Andrew kind of pointed out I could do it easy. But I had to set it up like this to let the world know, hey, if I'm getting 34.4% growth per decade, that means for every 10 years that passes, my final population should be 1.344 times my initial population. So I'll divide both sides by P naught. I'll take the log natural of both sides of the equation. And then I'll divide both sides by 10. And that's going to get me log natural 1.344 divided by 10. I get 0.0296 as being my K. That's my continuous annual growth rate. Continuous relative growth rate per year, my continuous annual growth rate. So now I have an equation here. If the year 1790 means t equals 0, then I have this equation. Oops. Okay, I've got this equation. My initial population will be 3.9 million. My continuous annual growth rate will be 0.0296. And this gets me my population for any year, you know, in the first 15 years of our nation's history. In fact, we'll even use this equation to predict the population in 1850. Let's predict in the year 1850. We've got 1840 right here. You tell me, if I'm going to use this equation to predict the population for 1850, and 1790 means t is 0, what is t is going to equal for 1850?
Oh, wait. 60?
Yeah, 60, right? 60. So t equal to 60. So I'm going to get p of 60, and that equals 3.9 times e to the 0.0296 times 60. Okay, so I got 3.9 times e raised to the power of 0.0296 times 60. Okay, so I get approximately 23.0 million. Okay, that's my prediction for the year 1850. In fact, in the year 1850, the actual population was 23.2 million. So you have the situation that somebody in the year 1800 could have accurately predicted the population 50 years in the future to within, you know, less than 1%. I mean, that's incredibly accurate ability to predict, as long as this holds true, as long as our annual, you know, relative growth rate remains constant. In fact, I'd like everyone right now to please go ahead and predict 1860. And go ahead and predict 1870. Go ahead and predict those years and see what you get. And I'll do the same, because is that 31? Wait. And all righty. Are you guys getting those predictions for 1860 and 1870? Okay, good. And in fact, in 1860, our prediction is 31.0 million, but in fact, in 1860, it was 31.4 million. Again, you're only off by about 1%. 1870, we predict 41.6 million, and the actual population was 38.6 million. Now suddenly we're off by something close to like 10%. Why am I so much far above what the actual population was in 1870?
The growth rate and the growth rate.
Okay, the growth rate decreased. You guys okay with that? Suddenly, I'm not doing this anymore. My relative growth rate is no longer 34%. It suddenly became a lot lower between 1860 and 1870. Did anything happen during that decade that might have been responsible for a reduction in the growth rate?
Civil War.
Yeah, the Civil War. Okay, well, thanks.